Today's focus will be on photovoltaics. What I want you to note on this image is this is a lot of solar panels. That's what we're talking about, photovoltaic cells, is you're using photo, which is like light, and then voltaic is like volts. So you're using light to make energy. What this is this is an array field. So we have a lot of solar panels basically, and what they're doing is they're generating a lot of electricity. This one, in fact, is actually in Illinois and Chicago. But what's really cool about these particular solar panels is that in order to maximize the amount of electricity, what you need to do is be able to have these individual panels be able to rotate and track with the sun. If, for example, they did not do that and you had the sun only on this side, only when the rays were coming down on this side would these solar panels actually work. But when the sun goes across the sky and is now on this side, if these panels did not rotate with the sun, they would not be receiving the same amount of energy from the sun, and therefore they would not be producing as much electricity as they potentially could. So it's really important for these fields to be able to track the sun. All right, so what is a photovoltaic cell? So we're going down to the very little bitty pieces within a solar panel, and what are they actually made out of? What they're all made out of are silicon, germanium, and boron. Germanium, I don't know why I said germanium. Germanium, boron, and phosphorus. These are all your 4 semiconductors. What a semiconductor is, it can conduct electricity, but it only partially can't. That's where the semiconductor comes from. So it's semi, so it partially can conduct. And it only can conduct electricity under certain conditions. This makes it a lot easier to control the amount of electricity that you get. So you want to be able to use these 4 semiconductors as opposed to using copper and silver, which are just pure straight out conductors, because you can control what happens with these electrons a little bit easier, making it more efficient to actually conduct electricity in the way that you want it to. So let's circle the elements that are used in PV cells. Remember, there are 4 of them. And if you look at them, what do you notice about them on the periodic table? Well, you should notice that they are all relatively close to one another, and that makes sense when you look at a periodic table, that things that are close to each other have similar properties. All right, so what I'm going to do on this is I'm going to describe what happens with the photovoltaic cell. We're going to kind of ignore this first step, okay, because this is kind of how we get it when we actually get the cells individually. All right, like when you get them shipped to you and you have your little solar panel or your solar little cell, this is what it'll be already made. They transfer this to this. Okay, so what I want you to notice is, first off, you have 2 basic layers. Okay, you have an N layer and a P layer. What you should notice is that there's more negatives on this P layer than on the above layer. Okay, what these guys are, erase this. What these guys are, these little spaces, is they're actually openings that can accept an electron. So it's basically a hole. We'll call it a hole. And so any electron can move right on up to there if they wanted to. Okay? But these electrons do not do that unless they are hit with something. And what hits them are actually these photons from the sun. Okay, so the sun is releasing light energy in the form of photons. What they do is they strike this solar cell and it kicks these electrons out. So it's actually able to use its energy to force these electrons to move. These electrons are then going to move to the holes that are found on the N layer right there. So these guys are going to move up to the N layer. Any hole that they can, any electron that's hit will try to move to a hole on the N layer. So then what happens is you've got this 4th step. So what they're doing is these electrons are moving up to your N layer, and then they join the circuit, okay, where the electrons are flowing. And now what they're going to try to do, they just moved up here, they're going to try to go back to their home base. And when they do that, what you notice is that the electrons are moving. Okay, so once again, you see the electron, it's been hit by a photon. It's able, the energy from the photon, or the light energy, is able to move that electron up to the hole found in the N layer. These electrons feel the need to go back to where they originally came from. By creating this, you have now created a circuit which then can conduct electricity. So really key, this is going to be on your test. In the diagram below, what is the only item that moves? Okay, and this is what the cell would look like, by the way. It would be the electrons. And because the only thing that are moving are electrons, there's no wear and tear on any of these pieces. So solar panels last like 10, 20, 30 years long because there are no moving parts on this other than the electrons. That's what makes solar panels such a good investment as opposed to, let's say, a wind turbine where there's moving parts always. These guys only move the electrons, so therefore you don't have the grind of daily use where you then have to be replacing things all the time.